Hello and welcome again to this new tutorial about the B4. Today we want to focus on the adder. We've already seen in a previous tutorial that it can add two binary numbers. Today we want to take the lid off the adder and have a look what is happening inside. So imagine for a moment that we were able to take the lid off this little black box and looked inside. What would we see? Well, in the first step we would see three different types of components. One that we call an AND gate, one that we would call an OR gate, and the third, this one, is a NOT gate. What do they do? The NOT gate inverts the signal, so a 1 becomes a 0. So it does the opposite of what you put in at the output. The OR gate will produce an output if one of the inputs is high, and the AND gate will produce an output if both of the inputs are high. Now an adder consists of just these three types of components, but quite a few of them. What we have done is we have linked them together. Let's take a look. This construction here in front of us has half the functionality of our adder. So we've left it at half because otherwise this construction would be double the size. So we kept it simple. However, we can plug it in and see what it does. So we just connect our power. Alright, so it's coming alive. This is our input. This is where we set our numbers that we want to add. Like with the adder in the previous tutorial. We have two of the manual programmers, two variables that we want to set. This circuitry down here are adapter modules so that our manual programmers have enough power to drive the relays. Relays are electromagnetical switches. Just like the transistors here, they switch, however they're mechanical, so we will hear them work. You will see that all the green LEDs are on. Here at the top is again the decimal display that we already know of. And these boards, you look at closer, here's an AND gate, here's an OR gate, over here is NOT gate, AND gate again, AND gate, and OR, and so forth. So we're really only using these three types of gates. Alright, so let's have a look. Let's set the one number, set to 1. Okay, something's happening. And what do we see? 1 plus 0 is 1. So far so good. Let's turn this variable to 1 as well, so the result should be 2. Okay, so something has happened again. And the result is 2. So 1 plus 1 is 2. Great. Let's add a bit more. 1 plus 2 is 3. And 2 plus 2 is 4. Okay, so let's do this a bit quicker. 0 plus 0, 0 plus 1, 1 plus 1, 2 plus 1, 2 plus 2, 1, 0, 1, 0. So 1 plus 1 is 2, 1 plus 2 is 3, and 2 plus 2 is 4. Alright, so decimal display. So as you probably agree that this is a rather complicated setup, it works. But for easiness and convenience, we ship the B4 with a semiconductor version, which is this chip. This version here, although it works, what disadvantages does it have? Well, first of all, lots of wires, mechanical parts, which limit the speed at which this thing can operate. This here can operate millions of instructions per second. This one could operate far fewer than that, maybe a few dozen, maybe 100 if you're lucky, instructions per second. And that's why today's computers use semiconductors and not relays. Okay, I hope that was interesting. See you soon.